Bonjour à tous, bienvenue dans cette avant-dernière session des DataXDays. Donc aujourd'hui, en fait, on va parler de Kafka et de ksqlDB. Donc le talk sera en anglais. Donc à partir de maintenant, je vais switcher en anglais. So the talk will be presented by Robin Moffat, dev advocate at Confluent, Kafka lover. So we will build a data pipeline in streaming mode. About the questions, it will be in the comment section of the YouTube video. Let's go. Thank you, Robin. Let's go. The public is yours.
My name is Robin Moffat. I'm a developer advocate at Confluent. Confluent, one of the companies behind the open source Apache Kafka project, and also with our own Kafka distribution called Confluent Platform, our own managed Kafka as a service in the cloud called Confluent Cloud. I've been doing this for quite a few years now, starting off with data warehousing, data engineering, doing that kind of thing, finding my way via big data and Hadoop and into the world of Kafka nowadays. I do lots of talks, I do lots of blogging. I've even started a YouTube channel thanks to the COVID lockdown. So there's links to those at the bottom. I also do lots of tweeting. So if you do the Twitters, then I'm off. It's always good to hear feedback, good and bad, about these talks. So today we're going to talk about building event streaming pipelines, which kind of sounds funky, but I want to start off by setting kind of like a base understanding for what we're actually talking about when it comes to Kafka. Kafka is an event streaming platform. And what that means is it can sit at the heart of many of our different architectures and enable us to flexibly and scalably and reliably loosely couple our systems, but in a very powerful way, such that it can be driven by events and share data in the form of events between them. So Kafka itself, at the very heart of it, is based around this concept of a distributed commit log. So the log, it's actually a very, very simple idea. Something happens in the world, whether it's in your application, emits an error, or an IoT device emits a reading, or a customer walks into a shop, or probably onto your website nowadays, and they buy something, or some inventory moves around in a warehouse. These are all actually just events. And we put these as events onto the end of this log. And it's append only. We just put them on the end of it. We don't go back and change them. And hence we say it is immutable. You can't go back and change an event that has happened. You can add in other events to counteract them. So you take a stock reading and your stock reading was wrong. Well, you put in another stock reading after that to counteract the first one, but you don't go back and change it. So it's immutable, it's append only, and it's distributed. Kafka is a distributed system, which means that we can scale it a lot, and it has very, very high fault tolerance properties. We divide this concept of a log up into what we call topics. And topics, if you're from a database background like me, they're kind of like tables in a database. So we say we've got a different topic for clicks that we have on a website, or a different topic for orders that get placed. We could also have a topic for what we would think of as reference or lookup data, like customers, because these are also just a series of events. A customer registers on our website, they get created, and then they change their email address, or they move house, or whatever, and all these different things happen to the customer, to this reference information, and they're all a series of events. And the great thing about capturing all of your data as a series of events, you can replay your events like clicks and orders, kind of like as you would expect to, and work through those in order. But you can also take your reference, your lookup data, and you can replay that and build it into state. And state's what we usually think of when we think about putting data into a database. But in a database, we just have this lump of state. Whereas if you capture the events, you can reason about the events themselves and when did they change address and how many times have they moved house. But you can also rebuild your state at any point that you want to. And then you can take that state and you can rebuild it either within your application as a state store in your application, or you can take that state and go and put it into a data store, or a database, or a NoSQL store, or wherever you also want to have access to it. But because of this powerful foundation of the log and the fact that you can replay these events to rebuild state and replay what happened in your business, you can actually use Kafka as this system of record to power other systems. Within a topic, we carve it up a little bit further into partitions, and partitions give us our unit of scale. And within a partition, data is strictly ordered. There's a guarantee of strict ordering within a partition in topics in Kafka. The messages that we put onto our topics are just bytes, key value bytes, which from a database world kind of like is a little bit scary because we're used to saying an insert statement or a select statement. Whereas as users of Kafka, we now need to think about how we're going to manage these bytes. How are we going to serialize the data that we've got? How are we going to deserialize the data off the topic? And there's various ways to do this, some of them really good and some of them less good. The main thing here is we need to think about the schemas, and that's an entirely different talk in its own right. But if you want a kind of like a starter for 10, those 3 that I've highlighted there, they're really good ones, good ways to serialize your data with strong support for schemas, which kind of avoid you building systems which are brittle and kind of end up breaking or tightly coupling themselves together. And there are a couple of other ways which wouldn't be my first recommendation. When it comes to reading these bytes out of Kafka, to reading these events, Kafka itself is this distributed commit log, and it's written to disk on Kafka brokers, and it's spread out across brokers for scalability and fault tolerance. And when people read data from the log, when they consume messages from a topic, all they're doing is going to a particular point in that log and reading messages. Kafka says, here are the messages from where you got to last time, and here are your messages. It don't get deleted. Someone else comes along, they say, oh, I'd like to read some messages. They're completely independent of the other consumer. So they come along and they say, well, I got to this point last time. Kafka stores where they got to last time. And it says, well, here's where you got to last time. I'll give you those messages from there. Or they could say, well, actually, I got to this point last time, but then I made a mistake in my processing. So as a consumer, I'm going to ask Kafka to give me data from a different offset in the log. I'm going to reconsume all of the data, perhaps. I would like to populate a new database with a replay of all of these events to rebuild that state into the database. Or I've done some processing on it and there was an error in my code and now I need to reprocess it. So consumers can independently go back and forth within the log as they want to. But it's sequential access. You go to an offset and you scan through. Kafka deletes messages from topics completely decoupled from how they've been consumed. Kafka deletes messages from topics based on how you configure it to retain the data, which is based either on duration, so we want to keep data for 2 weeks or 2 years or forever, or size. We want to keep 10 gigabytes worth of click data. Or indeed, you can tell Kafka, I would like to keep this data forever. And that's a totally valid use case that plenty of people do. There's also a special case called compacted topics, where you keep the latest value for every single key. And that's another way in which we can keep data forever. But the way in which the data is read is completely separate from how we then decide to age out and delete data that we don't want anymore. And that how we keep it is based on the business process that we're keeping that data for. So very quick recap of what Kafka is to kind of like set understandings and expectations. If you want to know lots and lots more about it, go and download these books here. You can scan the QR code, you can go to the URL there. All of these slides I'll be posting online. So after the talk, I'll go and put them on the YouTube chat. I'll be tweeting them, so @armoff, follow me on Twitter. There's also, I've got a talks webpage that you can find easily enough as well, and I'll link to them on there. So all of these links, you can get through that. But that's Kafka. And here today, we're talking about streaming data pipelines, which are kind of we build on top of Kafka. So we're going to build pipelines that let us do things based around this concept of events, a low latency streaming of events. But why do we even want to build pipelines? Well, perhaps we want to take data from a database and we want to stream it from one database or many different databases, and we're going to stream it through Kafka, and we're going to put it into S3, for example. We want to do some analytics on the data. So we've got this transactional database over here. We stream the data into Kafka, and then we go and land it into S3. Or we've got the data in a database, and we want to take that same data into Kafka, or we're going to put it into HDFS. And because the data is stored in Kafka, it means that you can actually replay it from one place out to S3, from the same topic out to HDFS completely independently. So I have this concept of database offload, which is basically what I'm describing here. Taking data from one place, the transactional, expensive to run database, where we've got all sorts of really cool database things that we don't actually need when it comes to doing the analytics. So we take the data and we put it somewhere cheaper and possibly more scalable. The other reason, or another reason why we often want to build around Kafka for our streaming data pipelines is that in that first example I showed you there, we were simply taking data from a database and shoving it somewhere else. Take a copy of this normalized data set usually and go and put it into an S3 bucket or into a HDFS folder. And we're going to have to do something with that normalized data. We're going to have to denormalize it and filter it and cleanse it and so on. Whereas if we think about that data that's coming from the database in this example, a lot of the time we can actually enrich that data and process it as it passes through our pipeline. So we don't always want to say, well, we'll pick up the data from here and go and put it into an S3 bucket or wherever you're doing your analytics, and then we'll process it, usually in batch form. You can say, well, let's think we've got orders data, and we've got information about our customers, and we'd like to find out which customers placed which orders. For our order characteristics, how many customers living in a certain location place this type of order, and kind of traditional type analytics. Well, we could say, well, as these orders get created, they end up in Kafka, we enrich them there with information about those customers, and then we can write it out somewhere and actually do kind of near real-time analytics on that data that's coming out of the database. So we take the information about the order events from the database, the information about the customers. Both of these reside in Kafka, and those events from the orders that are getting created, they drive this lookup process against the customer information within Kafka. That's written out to a new topic, and we write that down somewhere else, like Elasticsearch or just another database or S3 or whatever, to do our analytics. But now we have a nicely denormalized, cleansed data set. Another advantage of doing it like this, though, is that we don't always just have a database on the left-hand side of this picture. Perhaps it starts off as a single database, but then things change. Things always change in IT. We have new technologies, new projects, new requirements, and whilst it used to be the database that was holding our order information, now we've got a microservice. We've kind of evolved how we're building things. We said, right, now our order is going to be created by a totally new service up here. That service is going to use the producer API to write its messages directly into Kafka when an order gets created. So now we have our customer information still in the database. We have our order information coming from somewhere else. But within Kafka, we just have two topics, which we're going to enrich one against the other and write out to a new topic. So using Kafka in this context lets us evolve how we're building things in a much more loosely coupled way than traditionally. So how are we actually going to build this? Well, there's two parts to building a streaming data pipeline. We've got the integration piece, kind of like getting it in and getting it out, and we've got the stream processing piece. So integration using Apache Kafka is done for us using Apache Kafka's API called Kafka Connect. So this is part of Apache Kafka. If you're using Apache Kafka, you already have Kafka Connect. And Kafka Connect is this framework that lets us take data in from source systems into Kafka and stream data from Kafka out to our target systems. So you can use it to do all sorts of end-to-end integration, or use it to drive applications with source data from upstream, or take data from applications that you're writing and push it downstream. So you can use it in any sorts of combinations that you want to. And using Kafka Connect, unlike the producer and consumer APIs where you need to roll up your sleeves and write some application code, with Kafka Connect, you just write JSON. You say, here's my configuration. This declares where I would like to get my data from, where I would like to write it to, and off you go. Kafka Connect manages the serialization, it manages the schemas for you, it manages a whole bunch else as well. It manages the scale out of this kind of work, it manages the restarts and tracking the offsets. All of those tricky things around integration, it manages for you. It's part of Apache Kafka, and that's why using Kafka Connect instead of trying to write your own is a very good idea. If you try and write your own, you're kind of just reinventing the wheel. So Kafka Connect manages the serialization, it has its own set of converters, and as a user, you just say, I would like to use this converter here, and off you go. It's a pluggable, extendable framework. So you can take Kafka Connect, you can say, I would like to plug in this particular connector here. I would like to use it with this converter here. So I've got data coming from an IBM MQ source. So we're going to plug in that particular connector, and I would like to serialize it into Kafka as protobuf. So I'm going to use that particular converter. You can optionally do transformations on the data as it passes through the pipeline as well. So you can use it to mask fields and drop fields and change data types and change topic names and do all sorts of manipulation to the data as it's passing through. So it's a very, very good way to manage your integration, both bringing data in from a source into Kafka and from Kafka pushing it down to a target. Where you get all of these different pieces is Confluent Hub. So you go to Confluent Hub, you type in the technology or the converter or whatever that you're interested in, and then that lets you do, just gives you the command to run to pull down that particular piece. It's all open source, the Kafka Connect API, so you can go to the Java docs, and if you don't find something on Confluent Hub that you want, you can just go and write your own, if that's what your thing is. So that's how we do the integration piece of stream processing. Streaming data pipelines. But now how about the stream processing bit? How are we going to do that? Let's have a bit of a think about what we actually mean when we talk about doing stream processing. We've got data coming in and we want to process it, and there's various different things that we want to do with that data, and there's usually several standard patterns that we want to do. So here's an example. We've got some data. It's coming from a factory, and we've instrumented all of the different robots and so on, and they're sending back these data points to us. So we want to maybe alert against the data if things are being produced on the production line, which are outside a given specification. We want to start to analyze the data and understand how that production line is faring. Is it doing well? Is it not? We maybe want to do lookups against the state of that data. What's the average temperature on a given instrument at a point in time? And sometimes the data that we work with, we simply want to pull it in, we want to cleanse it, and push it down to another system for further work. And we can do this using stream processing. So as these messages are arriving, as these events are arriving, we can start to process this data. We can use something like ksqlDB to do this. ksqlDB is built on top of Kafka Streams. Kafka Streams is part of Apache Kafka. So if you want to use Java to do this, you can do. If you'd rather use SQL, you can do that also. So here's an example of ksqlDB. We're going to select everything from the inbound stream of widget events, so that all the different robots have got their instrumentation. They're sending back information about these widgets. So we can say, select everything from this stream where the weight is above 120 grams. Because if it's over 120 grams, that's outside our specification threshold, and we need to know about that. That writes it to a new Kafka topic, and we can subscribe to that Kafka topic, and we can generate alerts, we can trigger events, we can say, well, pause the production line whilst we go and check it. But we can respond to these things in real time based on a filter that we've set. We can also take this data and start to aggregate it up. How many widgets have we produced per production line? We could apply a window to it. How many widgets in the last 15 minutes have we created per production line? And we can take this state that we're building, this idea of doing an aggregate function on the data that's coming in, and we can apply predicates to it further. So we can use the having clause, but we can also do lookups against this state store directly. So we can have a separate application which says, I need to know what the average temperature is against a particular sensor, and you type in the sensor ID, and you do a lookup directly against this state store that ksqlDB is holding in memory. We're going to have a little bit more of a look at this because it's an important concept to understand actually what it's doing and what it empowers. And we can also use ksqlDB or Kafka Connect to push the data that we're processing and maybe filtering and cleaning up, and we can push that down to other places. We're not going to do all of our work on this data within ksqlDB. We're going to use the most appropriate tool for the job. And if you want to do big ad hoc analytics or machine learning and that kind of stuff, you're going to push that down to somewhere like HDFS or S3 or BigQuery, and you're going to do your work on it over there. So ksqlDB and Apache Kafka gives you that ability to take these streams of data in and route them to the different stores where you want to write that data. So at ksqlDB here, the event streaming database, the reason we call it a database is because you can do key value lookups against the state, like I was describing. But whether you use it for doing stream processing and taking a stream of events and processing them and writing them back to a topic, whether you use it for doing this key value lookup idea, it all is driven by data in Apache Kafka. So ksqlDB and Kafka Streams, which it's built on, and underneath that, the producer and consumer APIs, they read and write data from Kafka topics. So ksqlDB gives us a nice high-level abstraction on top of this, using SQL to interface with it. We can say, process this data, filter it out for this condition, or transform these columns here using regex or string functions, or however we want to transform the data and modify the schema, whatever we want to do, and then write it back to a Kafka topic. That's kind of like the input-output of it. The input's a Kafka topic, the output is a Kafka topic. That Kafka topic we can process further, again using ksqlDB. So perhaps we want to daisy chain our transformations. First off, the data comes in and we cleanse it and we drop the fields that we're not interested in and write that back to a Kafka topic. Why don't we do an additional transformation on it there? Well, that cleansed data might be useful to drive other systems that don't want the additional transformations that we're about to build, but they do want that cleansed data set. So we can transform it once and use it in many different places. When we finish the work on it that we want to do, we can say, well, we've written that topic back to Kafka, and now we can push that down to another system. So we use Kafka Connect or ksqlDB to invoke Kafka Connect directly and say, take this transform data, these orders that we've joined with these lookups against the customers or however we've processed it, and push that down to an analytics data store. We can also say, well, we're going to filter this data and we're going to drive some microservices, some applications based on those events. So we've got a whole bunch of information coming in. We've maybe got all of our order information coming in. And we've got a service somewhere which needs to know about when an order moves into a given state, when an order moves into a shipped status, because when an order moves into shipped status, we've got a business process that needs to fire to go off and do something. Well, we have a service that kind of does that something that we've defined in the business process. It subscribes to the topic, and that topic we populate using a ksqlDB statement which says, select star from orders where status equals shipped. That now writes it back onto a Kafka topic, and our service simply subscribes to that topic. Our service doesn't have to go and look up that information from somewhere or subscribe to the original stream and filter it and cleanse it and so on. Our service just subscribes to a topic which we've populated using ksqlDB statement to say filter it like this. Now on the picture here, we've got ksqlDB as this big database icon because it has database characteristics, but they're actually applications that we're writing. So don't think of this as like your big reporting database with all your ETL happening in like that kind of the way that we used to do things and still do sometimes, with all of the downsides of that. The statements that I'm describing, the statements we're going to have a look at in a moment, these are just SQL statements which express what we want to do and which we deploy as applications. You can cluster ksqlDB, but you don't have like one great big cluster. You can cluster it for resilience and for scale, but you deploy ksqlDB as if it were an application also. So just like that service I was talking about, where it's going to do something when orders reach a shipped status with a business process logic embedded within it, you deploy that as an application because that's how we build applications. But ksqlDB we deploy in a similar lightweight manner. So the last piece of this is the DB bit. So ksqlDB actually used to be called ksql. And then we thought, well, actually, we can do more with this. Because within ksql, when we're building out our aggregations, we're saying select a sum of this and like keep a running total of that. That is manifested within ksqlDB as an actual state store. And so ksql evolved into ksqlDB because this state store is now exposed, and you can do key value lookups against that state store. So we can have a statement which is running within ksqlDB, kind of like a materialized viewing concept, which says, subscribe to all of these events about transactions against bank accounts and keep a running count, a running sum against the transaction amount broken down by account ID. So we've got like the balances in real time within this state store in ksqlDB driven by the Kafka topic. We can then, in our application, a user comes along, what's the balance for my account? My account is account number 42. And so our application says, okay, we're doing key value lookup against this state store. And ksqlDB says, well, the balance for account 42 is 94. So we're doing this key value lookup against the state store directly from our application. We don't have another store of data. The kind of like the common way to architect this would be like, well, you've got a stream of events and you do something with them, and then you write them to a database. You write them to a NoSQL store, and that's what drives our application for its lookups. Whereas actually, our application itself can do its lookups directly against the state held within ksqlDB, which is fantastically powerful. So these are the pieces we're going to use. These are the tools in our toolbox. So let's see an example of it in action. So we're going to shift over sample data sets now. And here we're going to have an idea of an e-commerce website. And within our e-commerce website, people can leave ratings. It's like every website everywhere that annoys you saying like, do you want to leave a review or a rating? And in some cases, people say yes. And those reviews that they leave get submitted through our application's website, producer API, directly onto a Kafka topic. So we have a bunch of events that look like this. There's a rating ID, there's the user ID, there's the star rating, was something good, was it bad, there's a message, what device did they use, the channel, was it a web, was it iOS, and so on. So it's just like a stream of events. Nice, easy events to get our head around, like stuff happens over time, reviews get left over time, so this is the data we're going to work with. So what are we going to do with it? Well, we're going to do several different things. We're going to want to analyze For all of these different reviews, are people happy or not? So let's look at all of the reviews that we've got and break it down by star rating. Let's say, well, within this data set that we've got a user ID, which is a foreign key out to a customer data set. So can we actually do something when we bring in information about our customers also into Kafka and join that so we can find out not only like what are the reviews that are being left, but broken down by our different customers. And our customers have got different characteristics. There's like they've got different club status. So is it like a VIP customer or a platinum customer? And we can say, well, broken down by those different groups of customers, which ones are happier, which ones leave worse reviews, and so on. Or we could say, if we've got a really important customer, like platinum status customer, and they're leaving bad reviews, we want to do something about that. But all of these questions, all these rhetorical questions that I'm giving, these are answered by the data that we're getting in real time. These events are arriving. We can join it to the information about the customers as they arrive and actually trigger events to happen based on those. So not only can we do the analytics piece and say, like, as this data comes in, keep an up-to-date view of the analytics, and we can see like another customer of bronze status has left a really good review and update the dashboard accordingly. But we can also say, if a platinum customer leaves a negative review where the star rating is less than something, let's go and trigger an alert, which means that we phone up the customer and say, well, you've spent so much money with us. We love you as a customer. We don't want you to leave. We're sorry you had a bad experience. Can we do something about it? And we can do that kind of thing in near real time, driven by those events getting created. So it's going to look like this. We're going to take the data. We're going to write it down to an operational dashboard on somewhere like Elasticsearch. We're going to enrich the data using ksqlDB to write the data back on to our Kafka topic. My slides are slightly wonky here, and we're then going to push this data. We're going to have like a push notification application, which is going to subscribe to that particular topic. It's going to go and send something to the customer ops team that says, here's our platinum customer. They left a bad review. Let's go and do something there. We can push all of the denormalized data set down into our data lake and set our data science team loose on it to kind of go and do their clever stuff as well. But we use the same source of data to drive these different purposes, these different requirements from the business. So let's see what it actually looks like in practice. All of the code for this is online. I'll share the links to it afterwards. So let's have a look. So to start off with, we've got our ksqlDB front end here. So I'm going to say show topics and have a look at the data that we've got in ksqlDB. So ksqlDB is built on top of Apache Kafka. So here are the topics that I've got in Kafka. So I've got one called ratings. So we're going to say print ratings. Show me the data flowing through this topic. So this stage here, this is just an Apache Kafka consumer. It's an easier one to use than some of the command line ones because I just said print topic and it goes off and it works out. Works out stuff like this. How is that data serialized? It says, well, the data serialized, the value is Avro. And we talked very briefly earlier about serialization and schemas, and Avro got the thumbs up or double thumbs up because it's a good way to serialize it. It's a nice small binary message, but we retain the schema in the Confluent schema registry. So when we come to read the data, we've got access to the schema. You can see it's got key as well. So the key matches the rating ID. And with that data, these are our raw events, and we want to do something with them. So what we're going to do is we're going to take that data and we're going to declare what's called a stream on top of it. So a stream in ksqlDB is simply a Kafka topic, but with a schema. Because if we remember Kafka topics themselves, they're just key value bytes. And those bytes we need to deserialize. And once we deserialize them, hopefully we can apply a schema on top of them. So we're going to do this. We're going to say create a stream ratings with this particular topic and the data's in Avro format. So we go and do that. And then we do this, which is really cool. Describe ratings. Tell me about this particular ratings stream. And it says, well, it looks like this. It's got a schema. And that schema came about because we're using Avro. So when we wrote the data into Kafka, the schema for that data was explicitly declared. It was stored on the Confluent schema registry. So when the consumer, whether it's ksqlDB, whether it's your own consuming application, whether it's Kafka Connect, anything can come along, it can deserialize the data and it can pull down the schema from the schema registry. So it's now got access to the full definition of that schema. And since we've got a schema, we can do things like this. We can project columns. So we can say, show me just these different fields from this Kafka topic. It says, well, here is this live view of that data as it's coming in. Here are the star ratings. Here's the channel on which they were left. Here's the message. You can say, well, that's interesting. I'd like to see messages on my Kafka topic only where the rating is less than 3. So the star rating is 1 to 5, 5 is brilliant, 1 is awful. Sometimes in the test data that you can see on screen here, 1 and 5s and the messages actually meet up. So here we've got a star rating of 2 and the messages no, which kind of makes sense. A star rating of 1, your team here rocks, doesn't make so much sense. But the point is we're filtering this inbound stream of data based on a predicate that we've declared, where stars is less than 3. This is just showing us the real-time events. What about all of that existing data in that Kafka topic that I said is stored by Kafka? Wouldn't it be nice to actually go back through that? Well, we can do this. Show me the earliest offset, or sorry, start at the earliest offset, and now show me all of the data. This is, well, here is all of that data. So ksqlDB has now gone back to the beginning of the topic, and it's processing all of that data, it's applying that predicate to it, and it's writing it out to the screen. And it's writing it out to the screen, and it just whizzes by, which kind of like looks fancy and cool if your boss is watching, but it's not so useful for actually using that data. So we're going to cancel that, and we do something much more useful now. We're going to take that data, and we're going to write it back to a Kafka topic. So all we need for that is this, create stream as. So in the database world, you say create table as select. Take this static lump of data here and write it over there, or write some of it over there. In the streaming world, take this live stream of data, this continuous unbounded stream of events, and based on the select statement, so the projected fields and the predicates, write some of it over there. So the existing data that's on the topic, if we set the offset back to earliest, and every single subsequent event that arrives. So create stream poor ratings as just those fields from ratings where stars is less than 3. This time we don't get a stream of information on the screen because that select statement is now writing back into a Kafka topic. If I say list topics, it says here are your topics, you've got a new topic called poor ratings. And if I say print poor ratings, it says here is that particular topic. So let's pause that on the screen so we can see what's happening. But in our Kafka topic, we've now got just the fields that we asked for, the user ID, the stars, and the channel. And the stars, you can see, are 1s and 2s. They're less than 3, which is the predicate that we defined for that particular stream. And we can see, if we look at the poor ratings, you can do a describe extended against it. So not only do we get to see the schema, and the schema matches those fields that we specified, you can see the queries that are writing into it. You can also see the metrics. Because this is an application that we've written, there are metrics which are updating. If I keep on refreshing that describe extended, you can see that total messages value there, that 4301, that keeps on going up because we've got data arriving all of the time. So you can see the throughput that you're getting on that as well. Excuse me. So let me show you another example here. So at the bottom of the screen, we're going to have a second ksqlDB window. And at the top, we're going to say, show me everything. So we're going to say, set the offset to the latest. So just look at the events as they arrive. Print the source topic, print the ratings topic. Okay, so that's our live stream of events as they arrive. And at the bottom of the screen, we're going to say, just set it to the latest again. So let's copy that. And at the bottom of the screen, clear that. We say offset reset is latest, so just show me the events as they arrive. Print the poor ratings. So top of the screen, source topic, bottom of the screen, our topic that ksqlDB is filtered using 2 SQL statements. One to declare the stream, a second one to declare the new stream, create stream as select. So you can see here, as the data comes in, we've got stars that are, in fact, let me just pause this so you can actually see what's happening. Up here, stars 2, 3, 1, 4, 3, 4. Okay, so there's our stars on our source topic. Down here on our output topic are the stars less than 3, but both of these are updating in real time. If you actually look and compare the 2 key values here, so for the rating ID, you got key 888, and then 888 was up there, but you'll see they filter from one topic to the other only where that condition is met. So taking one Kafka topic, writing it out to another based on a predicate itself is really useful because you can drive other applications based on that Kafka topic that we're writing at the bottom there. Let's get a bit more involved in it now. Let's pull in our information about our customers. So what we're going to do is we're going to load up MySQL, which is where our customers reside. So our customers reside in a relational database. There's no surprise there. That's how we've often built these things in the past. So we don't want to load that one. We want to load this one. So at the bottom of the screen, I'm loading up MySQL. and we're going to say show tables. Which tables do we have in my MySQL database? Well, we've got one called customers. I can say select star from customers, and it says there is your data in customers. So we've got information, if I page up, about our user ID, their first name, their last name, their email address, their club status, because this is what we're going to filter on. So they bronze, they platinum, and so on. It's just a static lump of data, a state that we're holding in a database about our customers. But our customers have got a customer ID 1, customer ID 2, and so on. And we're going to use that to join out. If we just remind ourselves what that source data looks like, we're going to join it to this user ID field here in our source data. So user ID 4, we can find out from here is Hashim Rumk, and so we can join those together and write the enriched thing as that event arrives out onto a new Kafka topic. So we're going to get the data in using change data capture. And change data capture is another talk in its own right. When I share these slides, I'll share some links to some other talks, and one of them I've done is called No More Silos, integrating Kafka and databases, and it goes into the real nitty-gritty of what are your options and which one should you use. For now, we're using the MySQL transaction log, the bin log, to take every single change plus the existing state of the table and stream that into a Kafka topic. So up in ksqlDB, we're going to create our connector. Looks like this. So we're saying create connector. Let's page down a bit and clear so you can actually see what's happening on. So create source connector MySQL. We're using this MySQL connector. So this is Kafka Connect, just using ksqlDB as the control interface for it. But it's Kafka Connect under the covers. So we're using the Debezium MySQL connector. We're pulling in data from this particular table, and it's going to load it into a Kafka topic. It's not only going to load it, but it's going to keep that Kafka topic refreshed with every subsequent change to that source table. So if we say show connectors and make sure that it's working, it says it is working. So we've got a source MySQL here, and it says it's running. So now what we can do is we can actually look at that data itself. So if we say show topics, we can see here we've got a topic called customers, and that topic, so if we say print customers, and what we need to do is we also need to say, because we'd set offset to the latest previously, and we said print, and it said like, yeah, I'll wait for any new rows to arrive. Now we need to say print it from the beginning because we want to see all of the existing data. Because at the moment there's nothing new arriving on that topic because we don't have any changes to the customer data. So there's our data from the topic, and we just run the consumer against it, and you'll see it matches what we've got in that database in MySQL. So now we're going to create ourselves a table in ksqlDB. So ksqlDB has got two primary object types. It's got streams, which we saw before, a topic with a schema, and it's got tables. And tables are state. Tables are for a given key, what's the latest value. So that's what kind of like a customer information looks like for this particular customer ID. What's its current value? So saying create a table against this topic here, and you'll notice we're building it against the topic, and a topic is just a stream of events. And we could say create stream customers if we wanted, but it'll model it differently. But it's powered by the same concept, powered by the same data that's stored in Apache Kafka. So we create a table, and then we can query the table. So let's run this bit, which says, go back to the earliest offset, and then select out just these fields from the customer table in ksqlDB. And if I run that same thing in MySQL, so let's go down to the bottom here and say, select those from here, like that, you can see we've got pretty much the same thing, give or take a bit of formatting, in MySQL as we have in ksqlDB. So in MySQL down here, we've got all our different users with platinum and user ID and so on. And then up here in ksqlDB, we've got the same thing. We've got the user ID, the first name, the last name, and email. So this is the building block for being able to join information about events as they come in to look up information that's held elsewhere. Now I'm taking information from a database, from MySQL database, but this could be from anywhere. This could be information held in a flat file, in a message queue, in anywhere else. But we can bring this data into Kafka and we can then join it. So let's see what happens when we join it. We're going to do this. If you keep wondering why I keep looking up and down, I've got this cheat sheet here on my lower screen down here. And the reason I have a cheat sheet is that live demos go horribly wrong if you don't have one, however well you think you know it. And the other reason for a cheat sheet is that it means I can share it online and you can go and try it all out afterwards. And all you actually need is Docker and Docker Compose. So here is my statement that I'm going to run. I'm going to say create stream. So create stream, I'll select like we did before, create stream, ratings with customer data. So now we're doing a bit more of a complex SQL statement. And I say complex, but it's hardly complex SQL, but it's a bit more than just like select star with a predicate. So create a stream, we're going to use a custom topic name here because sometimes that's useful. You can override the partitioning and the replicate count and so on, but you don't have to. Select out the rating ID, the message, the stars, and the channel. Now bringing information out our customer ID. We're going to do some concatenation here. So you can do that kind of schema manipulation within ksqlDB. We're going to change the field name, select from ratings, do a left join to customers on this primary foreign key relationship. And we're going to say, let's run that. And it says, okay, I've created that query. And if I say show streams, it'll hopefully say I've created a stream as well. And we've now got a stream called ratings with customer data, which is backed by a Kafka topic called ratings enriched. If I say show topics, we'll see ratings enriched as a particular topic. And if I say print topic, it's going to say, here is all of your information. So let me pause the screen. And now we can see as these ratings are arriving, we've got the rating ID, we've got the message, we've got the stars. We've also got the full name, the club status, and their email address. So now we're taking these events that already existed on the topic, and we're enriching them with lookup information. And then every single subsequent event that arrives, if we just cancel that, so this is now a live stream of those changes. So the time there, 11:41 UTC, it's 13:41 in Central Europe. And you can see this is the live stream of events being enriched with information from the database. If I show you this, so I'm going to select from that stream. So instead of just dumping the topic as a consumer, let's just query that stream. Select from that stream where from ratings of customer data where ID equals 2. So just show me information where the user ID is 2. So at the moment, that's Ruthie Blockhurst, who's platinum status. If I say in my SQL at the bottom of the screen there, update customers, set first name equal to foo, where ID equals 2. I'm just going to say that's not working, which is why you have a cheat sheet where ID equals 2. And it says, okay, I've done that, I've made that change. So now next time we get an event on the top of the screen here for user ID 2, it's going to come through with our updated username. So at the moment it's Ruthie Blockhurst. If I keep on talking, any moment now we're going to get a new event that comes through, hopefully, and it'll say Foo Brockhurst, just like that on cue. So we can see Foo Brockhurst because something changed in the database, and names changing less likely, but club status certainly. So we've now got a live stream of changes doing lookups against that real-time state in the database. And why is that useful? Because we can now take that information, we can create a new topic. I'll just finish this little bit here. So create that stream there, unhappy platinum customers. So now we're taking that ratings there, filtering it where stars is less than 3, and club status is platinum. So that's now writing out to a new Kafka topic. And we can chuck all of that down into Elasticsearch. So create sync connector, take that data from these 2 different topics here, send it over to Elasticsearch. So show connectors, make sure that's working. And it says, yep, that's working. And if we now head over to Elasticsearch, to Kibana. Okay, a bit of background noise on the line there. And we can hopefully refresh that, and that's going to load up. And this is going to show us the live stream of the data from that source of event on our website, streaming through ksqlDB, being enriched with information about our customers and giving us this nice real-time dashboard here. So I could set the refresh time and so on, but I've kind of run out of time now, and I want to show you a couple of useful resource links. We've got a live stream of those changes. We've got separate topic for platinum customers who have left negative reviews that we could use to drive a notification up. So that's an example of a streaming data pipeline that you can build using Kafka, using ksqlDB. So in the 30 seconds I've got left remaining, I want to share some useful resource links with you. Again, those books, fantastic place to start understanding the fundamentals of Kafka, the kind of like the guts of Kafka and everything in between. Go and try out Confluent Clouds. There's various codes that you can use there for getting money off towards your bill. Again, I'll share these links in the slides afterwards. Go to developer Confluent.io so you can learn loads more about Kafka. There's videos, there's podcasts, there's tutorials. If you want to interact with the community, come along to the Slack group. You can scan the code, you can go to the URL. I think there's like 17,000 people from the community on that Slack group. You can chat with them then. There's different channels and so on. There's like ksql, there's Connect, and more. Finally, thank you very much for listening. I hope you enjoyed it. The slides are online. There's a bunch of other talks that I've done here. You can go to those URLs. You can even go and subscribe to my YouTube channel and take my humble number of subscribers just a little bit higher. But there's some more resources for you there. So with that, thank you very much. I think I'm out of time, but someone will correct me if I've got any time for questions. If I haven't, I'll answer them on the YouTube chat now. And if I can't do it there, I'll do it over on Confluent Slack. So thank you very much, everyone.
Thank you, Robin, for the talk. It was very relevant. So for the moment, we have one question. Where can we find the complete list of connectors?
So in the complete list of connectors, let me show you. So this is the useful thing about answering these things online, because you can actually answer them like this. So confluent.io/hub or hub.confluent.io. And here you can say, I'm interested in integrating with JMS. And it'll say, okay, here's the JMS sync, here's the JMS source. And so that's where you get all your different connectors from. You can go and troll GitHub and kind of like build your own and so on from there, but Confluent Hub just makes it much easier because they're pre-packaged. If you go and click on a particular one, you'll see there's a command that you can run, Confluent Hub install, and you just give it the name and it pulls it down.
Okay, super. We haven't another questions for the moment. You can ask, for instance, in the comment section of the YouTube video. Don't forget to send us a little feedback. We have a Google form in the video section inside the video title. We have two talks this afternoon, one in English and one in French. Donc nous aurons deux talks cet après-midi, un en français et un en anglais. The first one is about DevOps for machine learning, what it is different, presented by Ryan Dawson. And the second one in French, réentraînement automatique de modèles TensorFlow avec AWS par Sarah Hakim et Julien Chéant. Merci beaucoup. Thank you for your talk, Robin. Oh, we have questions.
Thank you very much.
Yeah, we have questions. Thank you for the presentation. Where can we find the code of the demo?
Okay, so again, let me show you two links before I let you all go. So talks.armoff.net is where all of my talks reside. This one should be online very shortly, and it includes all of the links underneath. So you click on a particular talk and you scroll down and it will have links to the demo code. You can also go to the Confluent Inc. demo scene repository. And this is again where all of our different demos live. So building a streaming data pipeline, that's on there. So you can go and try it out from there also.
Okay, super. Thank you, Robin.
Thank you very much. Goodbye.
Ciao, ciao.